Okay, friends, so today I have a huge and uphill task of trying to enlighten you on one of the most futuristic and extremely complicated technology called thought recognition. See, this is a process by which one can understand and appreciate what is the thought process going on in another individual. Its applications are immense and unbelievable. In the course of this lecture, I will be trying to highlight the tremendous applications of this technology. To understand thought recognition, we need to understand the currently available and rather complex technologies like face recognition and voice recognition, how these things work. As you know, these are all done by artificial intelligence. So it has a network of neurons exactly like human brains. Let's take a look. What you see on screen is a face recognition system which is trying to mimic or imitate the human brain. So you see a complex set of neurons or nodes. The first row is called the input row and the last row is called the output row, and in between you have several rows of hidden neurons. Now let's say this is the first screen is on face recognition. Let's see how it works. See, you have trained the system to recognize two guys, that is Jim and Tom. In the sense, you have actually run the images of Jim and Tom many times in the system and train the system to recognize these two guys. Now what you do is, Jim and Tom were clean shaven. So now you put on a beard, you put on a pair of sunglasses, and then try to see if the system can differentiate Jim and Tom. Okay, so Jim and Tom, who were clean shaven men, are now having beards. They're wearing sunglasses. So it's literally impossible for a human being to differentiate Jim and Tom now. But then you cannot fool the system. Let's see how it works. As you can see in the display, the first row of neurons or nodes actually check a part of the nose. See, for example, Jim has a nose and it has certain precise measurements. So the first set of neurons check out 1/16th of nose. The first neuron checks out 1/16th of the nose of the image. So that means you need 16 neurons to complete nose, or 16 nodes to complete nose. The second set compiles 1/8, that is, it compiles the output of two of the neurons in the first row, and now it has a compiled score or a compiled image. The next row of hidden neurons compile two of the previous set of images. Now you have 1/4 of the nose of Jim and Tom. The next set compiles two of them. Now we have half the nose of Jim and Tom. And then the next set of neurons combine two of them, and now you have the full nose. Okay? Full nose of Tim and Tom, Jim and Tom. And the next set of neurons, what it does, it combines 1/8 of the face, 1/8 of the face of Jim and Tom. Okay? So you have now the compiled image of 1/8 of the face of Jim and Tom in each one of the 8 neurons, hidden neurons in that row. So you know that if you put together the output of 8 of those neurons, you will have the full face of Jim and full face of Tom. Okay? The output neurons actually classify and combine the full image of Jim and Tom. Now what happens? Jim has a score of 0.3, means 30% match with his earlier clean shaven image. Now Tom has 80% match with that image, means this particular bearded image that you are given is not that of Jim, it is that of Tom. I hope this sequence is clear. Let's check out how sound recognition, voice recognition works. Next slide, please. The same process, exactly the same process. The input neurons, a large number of them. See, when we speak, each one of us have a different way of pronouncing specific alphabets. We have different bass, tone and tenor for our voice. So the first set of neurons actually check out how much it matches with the voice of Jim and that of Tom. The second set of neurons combine the pronunciation of alphabets and check out the pronunciation of words. The next set further combines, checks out word combinations used by Jim and Tom. The next set of neurons go further, compare the usage sentences that Jim and Tom generally use with that of this particular input. And finally, the whole speech is compiled. Okay? In the last 8 neurons, we have the whole speech. Each neuron would have compiled 1/8 of it. So put together, you have the whole speech. And the output neurons check out how much it matches with Jim's voice and Tom's voice. See, please note again, it has only 30% match with Jim's voice. So it is probably not Jim. But it has 80% with Tom's voice. So this voice belongs to Tom. So however much you try to disguise the voice, you are caught. This is the voice of Tom. Moving on to the complex futuristic area of thought recognition, before which we will take a look at lie detection. This is a very simplistic test. See, look at this slide. What does a lie detector do? It will connect certain nodes and read the electrical pulses of the brain. When you say a truth, it's straight from your memory. You don't undergo a lot of stress. So your wave is more or less flat. When you say a lie, it's like the ECG of a person under stress. The waves are prominent. It is actually, there is ups and downs in the wave pattern. Means you're trying to fabricate a lie. Very simple test, a lie detector test. Moving on to the complex world of thought detection. Now what this does is, it will record the wave pattern of each of the feelings of an individual. See, now the first wave pattern is when he is calm. Second is when there is light stress. Third, progressive stress. And next one is the depressive trend. Then when he is excited. And then when he is elated or very happy. We'll continue in the next slide because we're running out of time. Okay.